Hey there, folks. I'm going to take you through some of the basics of redox. This is sort of half of electrochemistry. Okay. Now, one thing you need to know about Unit 11 is that you may think you're heading right into Unit 11, and you may not realize that, oh man, you might not make it through Unit 11. But there are a couple things that are going to save you. Okay. Um, Leo says grr and understanding the term redox. Those are two things that are really going to help you. You've heard of these before. We talked about them in Unit 6. Anyway, they're going to save you in Unit 11. Leo the lion says grr, and the term redox. Okay. What does redox mean? Redox is two words put together, reduction and oxidation. Reduction is a chemical term that means something is gaining electrons. Oxidation means something is losing electrons. Okay? So a redox reaction is any reaction where electrons are transferred. One ion or atom gains electrons and another ion or atom loses electrons. Okay, so electrons move around, and actually this is how you can make electricity, okay, using chemicals. This is how a battery works. We'll learn about that in the second part of this unit. Leo the lion says grr. Loss of electrons is oxidation. Gain of electrons is reduction. You are going to use this over and over and over. Okay, another thing to remember, electrons cannot be destroyed and they cannot be created from nothing. Okay, so in any redox reaction overall, the number of electrons lost will equal the number of electrons gained, because you can't create or destroy electrons. I guarantee you, just remember this, it will help you with a mysterious multiple choice question at some point in your life. Okay, some general redox tips. When you see the phrase oxidation state, or sometimes oxidation number, that's just a fancy word for the charge on an ion. Your periodic table shows you selected charges, not every possible charge, but the most common ones, okay, right in the top right corner on your periodic table in the element boxes. And Leo the lion says grr. I usually go for the grr first. The reduction is easier to find first. Reduction makes more sense to me, the word reduction. In fact, let's explain that. The word reduction, where does that come from? It actually is very sensible, okay? Let's say we have some calcium that starts out in a reaction as a +2 ion. It's in some compound and it's an ion. And then eventually it ends up being a free element, which has a 0 charge. We'll talk about that in a minute. Okay, so it goes from a +2 to a 0. The charge was reduced. It went down on a number line. The word reduction means the charge is going down. The charge is being reduced. +2 to 0 is a reduction in charge. Okay, that's the word reduction. It makes sense. Okay, assigning oxidation states. Again, we did this in Unit 6. Here's a reminder. It just means figuring out the charge. First thing to remember, free elements are 0. What's a free element? An element that is only by itself, like H2 or Zn or Fe. Okay, they're not bonded to any other element. They have a charge of 0. Metals that are in a compound, you can look in your periodic table and you can use the formula to figure out the charge. We will analyze those two compounds in just a moment. Okay. For nonmetals in a compound, you often can just go for the top charge in your periodic table, but you may want to check the formula too. Okay, so let's just have a look and figure out the charges of some of these elements. Okay, oxygen, 99.9% of the time, oxygen is going to be a -2. And remember, a compound has a charge of 0. So this oxygen has a -2 charge. That means this iron must have a +2 charge. Okay, in this other compound, remember, iron can have a couple different charges. Okay, well, here we've got 3 oxygens. That's -2, -2, -2. That adds up to -6. The iron, there are 2 of them. They must each be a +3. That way, the minus charges are -6. The plus charges are +6. The whole thing balances out to 0. You could also think of this as the drop and swap method. We've talked about that before. Here we've got chlorine in 2 different compounds. Chlorine, let's see, okay, potassium is always a +1. That's always the case. Anything in group 1 is always a +1. Anything in group 2 is always a +2. this has to add up to 0. So here, chlorine is a -1. In this compound, okay, potassium is a +1. We got 3 oxygens, -2, -2, -2. That adds up to -6. +1, oh, the chlorine is going to have to be a +5 for the whole thing to add up to 0. Okay, so you do have to do a little bit of puzzle solving to figure out the charges sometimes, but you've done this before. Going to just show you a couple more examples. We're going to assign charges. Remember, a compound has a total charge of 0, and free elements are 0. Cl2, it's a free element. Charge is 0. Let's find the other free elements. Oh, iron, charge of 0. Any other free elements here? Oh yeah, O2, charge of 0. Those are free elements. Okay, NaCl, anything in group 1 is a +1. So that means the chlorine is a -1. And magnesium, anything in group 2 is a +2 charge. That means we got 2 chlorines here. Oh, a -1 and a -1. Each chlorine has a -1 charge. So the charge on chlorine is a -1. Yes, there are 2 of them in this compound. AlCl3. Well, aluminum is always a +3. Look it up on your periodic table. Chlorine, we've got 3 of them. It's a -1. Each chlorine has a charge of -1. Na2O. I know oxygen is almost always a -2. Oh, so each of the sodiums here is a +1. That adds up to 0 overall. Al2O3. Hey, the 2's and the 3's, the 3's and the 2's, we drop and swap. Okay. By the way, aluminum is always a +3. I'm just going to show you the math. 2 + 3 charges there. 3 - 2 charges. Oh yeah, +6 gets balanced out by a -6. The whole thing adds up to 0. Okay. Now, when we say Leo the lion says grr, I want to show you another way to think about that. Okay, grr means gain of electrons is reduction. Leo means loss of electrons is oxidation. You can write this and show the electrons. So magnesium 2+ is an ion. If it gains 2 electrons, it becomes magnesium 0. It was missing 2 electrons, it gained 2 electrons, now it is neutral magnesium again as a free element. So the electrons were gained, so we show them on the reactant side. They were gained, they were taken in by the ion, and now when we're done, oh, you don't see the electrons anymore because they're in there in the magnesium atom. Loss of electrons is oxidation. We see the electrons on the product side. We start with Na0 in this case. It loses or gives off 1 electron, so now it's Na+1, and here's the electron that it released. The electron is released as a product. The electron has been lost from the sodium. Now these reactions where we show the electrons, they're called half reactions. You'll see those over and over again. They just help us to track the electrons because eventually we want to make some electricity, and that'll happen in the second half of this unit where we talk about how to make a battery. Okay, but a half reaction just helps you track where are the electrons being gained, where are the electrons being lost. Okay, just going to take you through some examples here. Find the oxidation and reduction. The first thing you have to do if you're trying to figure out oxidation and reduction, write in all the charges. K, it's K by itself. Oh, it's the free element K. Okay, Cl2, it's chlorine attached to chlorine. It's not bonded to any other element. Oh, it's a free element. Okay, that's 0. And then here, you can ignore the coefficients. We're just focusing on the compounds. Potassium is a +1, chlorine is a -1. Okay, so potassium started out as a 0, ended up as a +1. Okay, the chlorine started out as a 0, ended up as a -1. I like to find the reduction first. Find which change is something being reduced in charge or going down. Chlorine going from a 0 to a -1, that's going down in charge. So the reduction is the chlorine 0 turning into chlorine -1. Okay, and if we wanted to, we could put a gain of electrons is reduction. So we could say, oh, the chlorine gains an electron, and then it becomes a chlorine -1 ion. So the chlorine gains the electron is shown on the reactant side. Oxidation has to be the other thing. In any reaction, you always have reduction and oxidation together. They can't happen separately. They can't happen alone, you've always got oxidation and reduction happening together. Okay, the other element must be the oxidation. Our K0 turns into K plus 1. Oxidation is when the charge goes up, okay? And for that to happen, LEO, loss of electrons, is oxidation. So if we wanted to, we could say, oh, okay, the electron is lost. Now notice, in both of these half reactions that I've written, the charge on both sides is equal. In the top one, I've got a -1 from the electron here, a 0 here. This side adds up to -1. Over here, this side adds up to -1. The charge on both sides has to be equal. Okay? In the oxidation case, I've got a charge of 0 over here. I've got +1 and -1. Oh, 0 over here. In these half reactions, the charge will be the same on either side. It won't always be 0. It won't always be +1 or -1. The charge will be the same on either side once you've written in your electrons correctly. All right, find the oxidation and reduction. Okay, let's see. We've got, oh, zinc is a free element. Okay, H is a +1 and chlorine's a -1. This zinc is a +2. Here, chlorine is now a -1. I'll just keep my numbers straight. And hydrogen by itself is a free element. I like to find the reduction first. So which thing changed charge and went down in charge? Well, hydrogen started out as a +1, ended up as 0. Okay, so H plus turning into H0, that's the reduction. Gain of electrons is reduction, GR. Okay, gaining electrons means electrons get added in on this side. In this case, it would be 1 electron. Notice, plus and minus, this side adds up to 0. Over here, this side adds up to 0. The oxidation must be the other thing that changes. The other thing that changes is the zinc, changing from a 0 to zinc with a +2 charge. Okay? LEO, loss of electrons, is oxidation. Oh, if electrons are lost, they must be given off on this side. Notice I'm using 2 electrons here because this goes from a 0 to a +2 charge. Okay? And overall, in this reaction, the number of electrons lost equals the number of electrons gained because these coefficients make it work out eventually. Don't worry too much about that. Anyway, notice the charge on the Zn0 side is the charge of 0. The charge on this side over here, +2 and -2, adds up to 0. When electrons are lost, they are on the product side. When electrons are gained, they are on the reactant side. Okay, one more. Oh, 2s and 3s, 3s and 2s. It's a drop and swap. So copper, in this case, must be a +3. Oxygen must be a -2. Chromium has a 0 charge. In this case now, okay, oxygen is a -2, and chromium goes to a +3. Copper is a 0. Let's find the reduction. Always find the reduction first. What thing goes down in charge? Looks like, oh, copper. Copper started out as a +3, goes down and becomes copper 0. So copper +3 turns into copper 0. For this to happen, GR, gain of electrons, is reduction. We must have gained 3 electrons. So 3 electrons joined with the ion to make this atom. Notice on the left side it adds up to 0, the charge adds up to 0. On the right side, the charge adds up to 0. The other change must be the oxidation. Oh, chromium starts out as a 0 charge, ends up as a +3 charge. Loss of electrons is oxidation. If electrons are lost, they are given off on the product side. And again, charge of 0 over on this side. Charge +3 -3 adds up to 0 on this side. Leo says GR. Charges are the same on either side. We got our correct half reactions. Okay, hey, boy, I'm doing lots of examples here. It's a free element. It's 0. Then silver is a +1 ion. Then we got copper as a +2 ion. And then we got silver. All I'm showing you here is you can also have reactions that are written with just the ions in them. They leave out some of the ions that are not really doing anything. Okay, find our reduction. Okay, and so that's a +1, that's +2. We've got silver as a +1 turning into silver with a 0 charge. That's a reduction in charge. And for that to happen, we had to gain electrons. Gain of electrons is reduction. Grr. Okay. -1 and +1, 0 on this side, 0 on this side. Our charges are the same on either side of the reaction. The oxidation must be the other change. The other change is copper 0 turning into copper +2. Loss of electrons is oxidation. For this to happen, we lost electrons. Remember, the charge on this side is 0. The charge on this side has to add up to 0. If you write the electrons on the wrong side by accident, then once you check, is the charge the same on each side of the arrow? Oh, whoops, I must have put the electrons in the wrong place. If I put the electrons over here, this side would add up to -2, this side would add up to +2. That would be a way to check myself and realize I got the electrons in the wrong place. Okay, write in the electrons to complete the half reactions. Identify each half reaction as reduction or oxidation. All right, you can do this in what order makes sense to you. Okay, we start with lithium as a 0. It goes to a +1. That's not a reduction in charge. The charge is going up. That must be oxidation. Okay, but down here, K +1 ends up as K0. Oh, that is a reduction in charge. In this case, the charge is going down. Now we have to write in the electrons. Which side do the electrons go on? Leo, loss of electrons is oxidation. Loss of electrons means electrons are being given off on the product side. If I wrote the electrons over on the Li0 side, that side would add up to -1. This side would add up to +1. The charges wouldn't be the same on both sides of this half reaction. Reduction, gain of electrons is reduction. The potassium +1 gains this one electron. That electron joins into it, and now it's a K0, a free element, the atom potassium. So again, when you have reduction, the electrons are always on the reactant side. When you have oxidation, the electrons are on the product side because electrons are lost. They are given off. They are produced. Okay, finally, you might get a question like this and you might want to cry, but don't cry. It's okay. There's a trick to this question. Okay, there's a trick to this question. If you want to find a redox reaction, you're trying to find a reaction where things change their charges. Okay, things change charge. The easiest way to find something, these questions are always the same, or the trick is always the same with these questions. There will be one reaction that has a free element in it. A free element on one side that's in a compound on the other side. Okay, so we got to just look for where is a free element, where is a free element, where is a free element. Aha, oxygen right here is a free element on this side, but it's in a compound on this side, so it's going to have a charge. Do I have to figure out the charge? No, I know that it had some charge over on this side, but now it's a free element on this side. Something changed charge. I found the redox reaction. Whenever you get a question like this, you don't have to figure out all these to find out what changed their charge. You don't have to calculate the charges for everything in every answer. Just look for the free element. Look for the free element, and then you won't cry. These questions will be so easy.